Okay, hello students. So we're back to our scintillation setup here, gamma ray scintillation. And in the last couple of videos I introduced you to the new NIM module called the single channel analyzer. And what the single channel analyzer does is it allows you to set sort of a voltage window, a lower level and an upper level. And if one of those pulses you see on the oscilloscope happens to come in here and cross between the lower and upper level and go down again, if it gets in this region here, the SA will put out a green 5 volt TTL pulse indicating yes, a pulse has gone between the voltage window that you set. So it turns out then the next question is, well, what can you do with a bunch of green pulses that represents the go-no-go presence of a gamma ray? Well, it turns out there's plenty. So I'm going to introduce you to another module. And here it is right here. We're going to put it in the NIM bin in just a second. It's called a dual counter timer. Okay, so it does some timing, does some counting. Sometimes these are called a scaler, and I'll show you why. So I'm going to pop it into the NIM right now, give it a push. See, it immediately comes on and these digits show up. And so let me do some settings on it now. What you can do with it is say maybe set a certain amount of time. And the time zone is kind of a bit of a pain to set on this, but we'll get that going here. So you have to sort of set it in a way as some power of 10. So if I do a 1 times 10 to the 1, that's 10 times 10 to the 1 power according to this label here. You can just see it on there. It says mn times 10 to the p. So m is 1, n is 0. That's 10 times 10 to the 1. So 10 times 10 is 100. And if I multiply 100 times this overall multiplier down here, which is 0.01, we'll get 1 second. So in other words, I just want to set the timer on this to 1 second. Let's see if I've done that. Yeah, see, it sort of counts up to 1 second internally, then it stops. And there's a knob here called the dwell time, which you can tell it how much to pause between the time it starts counting again. So see if I turn the dwell time up, you can see that I don't want to wait that much, but see it counts to 1, then it waits for a while, and then it counts again and it waits for a while. It counts again, it waits for a while. If I turn the dwell time up like that, then it'll wait a longer amount of time. And typically the waiting it does is to give you, the operator, a chance to write things down or see what's going on. That's what the dwell time is for. So see, that was kind of a long wait. Now I turn the dwell time down. As soon as it gets to 1, it pretty much starts over again. So anyway, that's sort of what that does. So I have it sort of set on a time base of 1 second. So what am I going to do with that? That's what the timing aspect is. What am I going to do with that? Well, it turns out what I can do is if I go back to the sort of the equipment here, let me go ahead and pull this channel 2 off the oscilloscope here. So our green pulses from the SA will disappear. We sort of know how that works now, so we don't need to see it on the oscilloscope all the time. And I'm just going to take that cable and I'm going to plug it into the input of this counter timer here. Okay, so it's just plugged in there. So right from the SCA into the counter timer. And if I go over to B here, which isn't the timer anymore, some counts, but see what it's doing now is these definitely don't look like seconds to me anymore. They kind of look like numbers coming in, 929, 946. We can mess with the dwell time to get it to count. The recycle cylinder 884, 924, 961. What this is doing is counting the number of times a green pulse from the SCA is seen. So essentially it's counting the number of gamma rays we see, and I set the time base to 1 second. So these numbers you see here would be gamma rays per second. So at the moment I'm getting about 991, 922. See, there's some fluctuation there. This is how many gamma rays per second I'm detecting in this setup here. So something like that is would be a little bit hard to see here, just exactly how many per second. And certainly you wouldn't even notice that just by putting the source on top of there, but it's sort of a useful quantity there that tells me sort of the activity or the hotness of my source. So just to convince you that it is coming from the source, if I take the source off of the detector now, see the count rate drops quite a bit. This is just background noise and things like that in the system to the tune of 25. And if I go ahead and put that source back on the detector, see, it just goes off again, counting all these gamma rays in there. And so this is actually a very useful device in the counter scaler, tells me how many gamma rays per second I am getting in to my system. So what we're going to do is about 2 things here with the scaler. Is we're going to take some data now with this scaler here that involves a really high count rate, just like this one you see here, and maybe we'll reduce it just a tad bit to match some other data. And then what we'll do a really low count rate. Let me show you how that's going to work. So what I can do here is I can turn up this lower level discriminator, remember, to discriminate out more and more pulses coming in. until we get sort of an average around, I don't know, around here, around 650, 620, something like that. Maybe 635, so we can get up a little bit higher, something like that. Okay, we'll sort of do that. And so this would be considered sort of a high count rate, about 600 or so gamma rays per second coming in, something like that. And then what we'll do is we're going to write a bunch of these numbers down, and then what we're going to do is we're going to increase this lower level here really high to get an extremely low gamma ray count. Okay, looks like I've gone a little too high there, something like this maybe. So I've raised that lower level so high that very few of the gamma rays coming through the system are actually getting counted by the SCA. So you see we're even getting some zeros and just some ones and some twos, and so this will be considered a very low count rate. So we're going to take two videos now, one to get about 100 high count rate numbers, and the other one to get a very high number of low count rate numbers. So we do about 100 numbers, some high and some low, and that'll be a data set we're going to get for this particular experiment. So we're going to use an SCA to do some gamma ray counting in a very high count regime and a very low count regime. It turns out there's some very interesting statistics and analysis to be done with that.